While the world's eyes were on the battle between BYD and Tesla, who will give more range, who will make a cheaper EV first, another giant company was building something behind the scenes, which no one had any idea about. Yes, General Motors, IEE, GM, was quietly working on a technology that could shake the entire auto industry to its roots. And now, that curtain has been lifted. GM has recently introduced an engine that is neither just an electric vehicle nor runs on traditional petrol or diesel. Rather, it is a zero-emission engine which breaks the boundaries of both worlds. This is not just a technological improvement, it is a complete revolution of thinking. It is believed that this engine can make both EVs and internal combustion engines obsolete and will change the very definition of the automobile. Experts believe that this could be GM's biggest game changer, and if it succeeds on a large scale, it will show a new path not only to the world of cars, but to the entire energy sector. Now the question is this really possible? Will a third player now win the race between Tesla and BYD? Before knowing about this new idea, new revolution, and this silent big move of GM, you must subscribe to the channel so that you get the most important updates in technology first. For years, GM has been looking for a solution other than electric vehicles that is not only environmentally friendly, but also addresses long range, low cost, and low charging dependency. In this search, they found new hope in an old but much overlooked technology, compressed air technology. You may be surprised to hear this, but the idea of using air as energy is not new. In the late 1800s, some cities in Europe, notably Paris, used this technology in trams and mines. But as petrol and diesel engines proved faster and more powerful, air-based technology was sidelined. However, around 2010, Peugeot once again saw the potential in this technology and tried to combine it with a conventional engine. Their hybrid system was able to deliver eco-friendly performance without a battery. But alas, the experiment never progressed beyond the testing stage. GM, on the other hand, took this technology seriously. They saw that if developed correctly, it could not only become a powerful alternative to EVs, but could also change the entire dynamic of the industry in the coming years. That is why they quietly, silently started R&D on it at a time when the whole world was rushing toward electric. Now that GM has taken this technology in a new direction, an important question arises. Does it really have the power to outperform both electric and fuel technologies? So how do these compressed air vehicles work? If you're thinking that they must be like a battery or petrol-powered engine, then wait a minute, because their mechanism is quite different and interesting. These vehicles neither burn fuel nor do they have the hassle of heavy batteries. Instead, their power lies in the pressure of air. Yes, these vehicles run on a special type of engine, which is called a compressed air engine or pneumatic engine. These engines look like any other engine from the outside: piston, cylinder, valve, etc. But the game inside is completely new. Here, no explosion or flammable fuel is needed to run the piston. Instead, high-pressure air is released into a chamber, which pushes the piston inside forward forcefully. After this, the piston is connected to a spring, which pulls it back once the air is released. In this way, the piston moves back and forth repeatedly, and this repetition translates into motion that turns the wheels. No smoke, no poisonous gases, just air and mechanical efficiency. What is most interesting is that the basic structure of this technology is very similar to that of conventional engines. This is why companies like GM saw potential in it. They felt that they could develop it quickly without making many changes, using existing technical solutions and production infrastructure. Now that we understand how a compressed air engine works, the next big question that arises is, what is so special about it that makes it different and better than EVs in petrol-diesel engines? So let's first talk about its biggest feature: 100% pollution-free technology. It does not burn any kind of fuel, nor does it emit any smoke or poisonous gas. Only air, which is present all around us, is used under pressure. That means not only is it free from greenhouse gases, but it also does not have any negative impact on the environment. But that's not all. It has another big advantage hidden in it that is often overlooked: cost. While electric vehicles require rare and expensive earth metals like lithium and cobalt to run, compressed air engines are not dependent on them at all. Cheap, common materials are used to make it, which makes its manufacturing much less expensive. And it's not just about cost. The production process is also much simpler. Because these engines don't burn fuel, they don't require strong or heavy metals. This means they can be made from lighter materials, which not only reduces the weight of the vehicle, but also makes it quicker and easier to build. Another subtle but important advantage over EVs is the cleanliness of the energy source. Even though EVs themselves are not polluting, the electricity to charge them often comes from coal or gas. Compressed air engines, which are not dependent on any grid, emerge as a clean and independent energy option. When it comes to operating costs, compressed air engines are a real hit. No worries of petrol, no charging lines. Air, which is available everywhere, just needs to be pressurized, and the engine starts running. Engines are a real hit. No worries of petrol, no charging lines. Air, which is available everywhere, just needs to be pressurized, and the engine starts running. They burn no chemicals, consume no metals, and emit no toxic fumes. And the best part? When the air leaves the engine, it goes out in exactly the same form as it went in. There is no wastage of any kind. It would not be wrong to call it a future-proof technology. But every coin has two sides, and compressed air technology is no exception. While its simplicity and cleanliness are attractive on one hand, on the other hand, it has some technical limitations, which are hindering its large-scale adoption. The first and foremost thing is that the energy density in air is very low. That is, if we compare the energy obtained from batteries or petrol, air does not have that much power. As a result, the engine has to be rotated very quickly at high RPM, making wear of its parts a common problem. In addition, the torque of a compressed air engine is very weak, making these engines less suitable for needs such as carrying heavy loads or driving on rough roads. Moreover, since there is no liquid fuel in them, they are not easy to lubricate. This becomes an additional challenge in terms of maintenance, and of course, another important factor is efficiency. Many people think that air is free, so there is nothing to worry about, but in reality, the efficiency of these engines is very low. The prototypes built till date have an average range of only 120 to 140 kilometers, which is not enough for long journeys. Now imagine if your car starts giving a fill air alert every few minutes. Will you be able to trust it for long distances? This was the biggest problem with compressed air vehicles in the beginning. The range of these vehicles was so limited that it could manage within the city, but as soon as you stepped on the highway, range anxiety would leave you hanging in the air again and again. And the biggest worry? Safety. Many of the early prototypes used ordinary steel tanks to store air. These were heavy, made the car slow, and most dangerously, if the tank ever got a shock or developed a leak, the tremendous pressure buildup inside could cause it to burst.